All right, so the lifeblood of an engine, any engine, is going to be its oil. Now, we're all pretty familiar with oil, I would think. If you own a car, you have to get oil changes. You'll see people who own aircraft will frequently either be doing their own oil changes or they'll be looking for someone to do an oil change. It's probably one of the most common maintenance things that you'll ever come across. Every year before I mow my grass, the first thing I do is change the oil on the mower to make sure that we have it for next year. Now, oil itself is actually fairly complicated. It's a fairly complex piece of technology. You wouldn't think it. It just comes in a little bottle and you pull it in there. But when you start breaking it down, all the different properties that it has and all the things that it does and how it impacts which oil you put into an engine or how you change the oil, all that good stuff starts to come into to play. So let's talk about engine oil and try to get a good understanding of it before we start talking about how it's used inside of a motor.
Okay, so the primary function of engine oil is to reduce friction inside of the engine. So let's kind of take a little step back to physics and just review the types of friction that you could potentially have. So on this graphic, at the top, we have a block that's just sitting there. So there's no motion. That means that there's static friction. So like one of the forces keeping that block from just like sliding around anytime the wind blows is the friction from the block to the surface that it's sitting on. And that actually has a quantifiable number. If you get into college level physics, you'll actually do some problems to try to calculate the level of friction that block is experiencing. The next one is a sliding motion. All right, so that gives us, if the block were to move, the force applied to that friction has to be greater than the friction, or the static friction that's holding it in place. So that it's back to Newton's laws that an object will stay at rest until a force that's greater acts upon it. Well, so in order to push the block, you have to overcome the force of that static friction that's there. The next one is a rolling motion, which exposes us to rolling friction. So if I were to have say a cue ball sitting on the hangar floor and I were to push it, eventually that cue ball is going to come to rest. And one of the factors that slows it down is just the friction of the ball on the surface. Now there's other things that help slow the ball down as well, but the friction is probably one of the greatest factors in getting that ball to just slow down. Now, if you think about it, this makes a lot of sense. If it's a nice smooth surface like a cue ball, it'll roll farther and farther. But if I get, say, like a pineapple and try to roll it, you're going to end up having a lot more friction because of the way that the surface is built, and it actually will slow the pineapple rolling down even further, or even faster. So we have to keep these in mind when we start talking about the function of engine oil, since the function of engine oil is to reduce friction. Now, the way that engine oil actually does this is it acts like a cushion between two metal parts. All right. Now, so instead of having two parts that touch each other, the engine oil sits in the middle of it like this. So the engine oil sits in the middle, allowing it to be a cushion between those two metals. So that way there's a reduced amount of metal-to-metal contact. Now, because of the coefficient of friction with the engine oil is actually lower, and it moves around and helps cool it and cleans it, the engine can continually have very close proximity metal parts, because we were talking about this cushion is like very, very, very microscopically thin. It's just enough to kind of coat the outside of the part as they touch together. That little bit of a cushion allows those parts to pass in between each other in a very close proximity and at a high rate of speed. All right, so this is Aeroshell 20 weight 50, so 20W50. It's a very common general aviation engine oil. There's a couple of different options that a lot of plane owners have, and typically this one from Phillips 66 is going to be what at least what I've seen to be the most common engine oil that you're going to come across. So let's just talk about some of the aspects of engine oil in general. All right. So first off is viscosity. You can think of viscosity as this: is the rate in which something can be poured. So if you think about water, has a very low viscosity; it pours very, very easily. Something with a very high viscosity, say like corn syrup or even maple syrup. it pours very, very slow. It also gets, as things get colder, the viscosity gets higher, so it pours even slower onto a plate or whatever. Our engine oil has different weights of viscosity, which allow us to dial in the operational environment that the engine is in, and then choose the right engine oil that will be appropriately viscous enough for that environment. So, for instance, if you wanted to have, let's say, if you're operating in a colder environment, you might want to go for a more viscous oil, so that way it'll pour a little bit easier, and it'll help circulate in the engine a little bit easier due to the cold temperature. If you want to operate, say, like Death Valley or something like that, you might want to have a more viscous oil, so that way it'll maintain its cooling properties longer, because the engine oil has to, or the engine has to heat up enough to get the oil to start to break down. And if it's already super duper hot, you need to kind of like dial that back in. These are things that you want to think about whenever you're operating an engine in some sort of, especially some extreme environment. Now, the owner's manual, your POH, will tell you what engine oils are authorized for that engine, and it may even break down and say, like, if it's operating from this temperature to this temperature, use this weight of engine oil, or this temperature, this weight of engine oil. And sometimes, many times, they will recommend use these engine oils, da, 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 or they'll say, or the equivalent at the end. So based on where you're at and what you have available, may change that. Now, all right, so this is Aeroshell 20 weight 50, so 20W50. It's a very common general aviation engine oil. There's a couple of different options that a lot of plane owners have, and typically this one from Phillips 66 is going to be what at least what I've seen to be the most common engine oil that you're going to come across. So let's just talk about some of the aspects of engine oil in general. All right. So first off is viscosity. You can think of viscosity as this: is the rate in which something can be poured. So if you think about water, has a very low viscosity; it pours very, very easily. Something with a very high viscosity, say like corn syrup, or even maple syrup. It pours very, very slow. It also gets, as things get colder, the viscosity gets higher, so it pours even slower onto a plate or whatever. Our engine oil has different weights of viscosity, which allow us to dial in the operational environment that the engine is in, and then choose the right engine oil that will be appropriately viscous enough for that environment. So, for instance, if you wanted to have, let's say, if you're operating in a colder environment, you might want to go for a more viscous oil, so that way it'll pour a little bit easier, and it'll help circulate in the engine a little bit easier due to the cold temperature. If you want to operate, say, like Death Valley or something like that, you might want to have a more viscous oil, so that way it'll maintain its cooling properties longer, because the engine oil the engine has to heat up enough to get the oil to start to break down. And if it's already super duper hot, you need to kind of like dial that back in. Uh, these are things that you want to think about whenever you're operating an engine in some sort of, especially some extreme environment. Now, the owner's manual, your POH, will tell you what engine oils are authorized for that engine, and it may even break down and say, like, if it's operating from this temperature to this temperature, use this weight of engine oil, or this temperature, this weight of engine oil. And sometimes, many times, they will recommend use these engine oils, da, 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 or they'll say, or the equivalent at the end. So based on where you're at and what you have available, may change that. Now, okay, let's talk about the flash and fire point. So, flash point basically is the point where the oil will start to give off gas that can be ignited, and so it'll flash, but it won't be sustained. Fire point is whenever it's hot enough to continuously put off that gas to burn and actually be a sustained fire. And so, like most time, if you see engine oil that's on fire, it's going to have to be above that fire point, because the oil itself won't necessarily burn, but what comes off of the oil will be burning. And so you'll see you'll see that. Now, all this engine oil is set to withstand like normal operating temperatures of engines. But this is also a reason why high engine oil temperature becomes a serious concern for a couple of reasons. One, it starts to lose its ability to cool the engine. Number two, you start approaching its flash and fire points, so it can catch on fire. And then number three, as it off gases, the closer it gets there, it starts building up more and more pressure, and the engine can only take so much pressure. I mean, just like anything, if you have like a water bottle in there and you just keep filling it up with air, eventually it'll pop. Engines are no different; they're just a lot more have a lot more strength. So that's something to keep in mind with engine oil. Okay, so the cloud point. The cloud point is the oil. A cloud point of oil is the temperature at which its wax content, normally held in solution, begins to solidify and separate into tiny crystals, causing the oil to appear cloudy or hazy. We've all actually probably seen oil that's like this. If you've seen oil that's set up for a long period of time, you'll start to see that happen. But there's an actual a temperature where that will induce this effect, and you don't want that, because the oil is actually, whenever they refine oil and then they add additives to it to do different things, there's a reason why they're putting that stuff in there, and it's for performance. And whenever the engineers are building an engine and then putting maintenance forecasts into it, and all those types of things, all of that is taken into account, things like the cloud point of an engine, or a flash point or fire point or whatever. So all of that data is then fed into the maintenance schedule, and then sent out to you as the maintainer to maintain that. So if the cloud point of the oil is off one way or the other, you're going to get effects on the oil that are not going to be conducive to good and healthy operations of that engine. So it's something to pay attention to. Okay, now the pour point. The pour point is the lowest temperature at which the oil can be poured out. It can be actually moved from one place to other. It's not necessarily become a solid, like it doesn't necessarily freeze, even though it can freeze. But it'll get so viscous that it's more like almost kind of like a really sticky gelatin or whatever. And that's whenever the temperature drops below the pour point. So oil has to operate above its pour point for you to actually do anything with it, or to move around inside of the engine. If not, it's like, the engine's just basically like beating some sludge at the bottom of the sump. So nothing good's going to happen there. Okay, now let's talk about specific gravity. So specific gravity is a comparison of the weight of the substance equal to the volume of distilled water at a specified temperature. So as an example, water weighs about 8 pounds per gallon. Oil with a specific gravity of zero point 0.9 would weigh 7.2 per gallon. All right, so that specific gravity is nothing more than just a reference. Like how heavy is it per gallon? And so and this will come into effect whenever you're looking at like weight and balance. We start talking about like how much does the usable oil weigh or unusable oil weigh? How much does the oil weigh whenever it comes into it? You'll never see specific gravity referred to in those situations, but that's what you're getting. You're getting like you could effectively say that like we had like 10 gallons of oil with a specific gravity of zero point 0.9, you would know it's 7.2 pounds. But in most documents, what they end up saying is they just simply say like oil weighs 7.2 pounds. So it's simpler. It's more to the point. But that being said, sometimes whenever you start digging into some of this engineering, you're going to end up needing to know what specific gravity is, and all it is. It sounds fantastic, but like all it really is just a reference to water. Water becomes the baseline that everything is compared to. So if something is 1.1, that tells us it's heavier than water per gallon. If it's 0.9, it's lighter than water per gallon. So oil will float on top of water because it's lighter than water. Water sinks; it goes to the bottom. And so that's what specific gravity is. And so yeah, so now we kind of have a general idea of oil. Let's see how it plays into the rest of the system.
Now, every engine has its own unique lubrication system. There's dry sumps, there's wet sumps. There's all kinds of little nuances to engine lubrication systems. In this class, we're going to focus strictly on reciprocating engine, unlike the PT6 that's behind me. In future classes, we'll talk about the lubricating systems inside of turbine engines, but that's going to come at a later date. So for right now, let's dig into the different types of lubrication systems that are on a reciprocating engine.
Okay, so this is kind of a high-level overview of a really basic oil system on a recip engine. Just kind of taking us around the clock there. We have a engine breather that's so that way the engine doesn't get over pressurized. It can actually like expel some air pressure if needed. You have a scavenger pump that's going to help the oil move around. You have an oil pressure pump that's going to be your main pump. And we're going to get to all of these in greater detail here in just a second. You have your oil temperature gauge, which obviously tells you the oil temperature. You have a flexible weighted internal hose assembly that basically now this is a certain type of system we're going to divide out, but like essentially you'll have another oil tank somewhere else, and you need to have a hose that does as it takes oil in or out. You don't want it to get above the oil line, so you always want to weight it so that way it comes down and falls to the lowest point where all the rest of the fluid is going to be. You have your oil tank drain valve. It's pretty obvious to drain the oil out of there. You have a scupper drain. It's another drain. We'll get into that here in a little bit. The oil tank vent obviously does the same thing, keeps it from overpressurizing. I remember on an OH58 on is a turbine engine, but we would get sometimes the that oil tank vent would get clogged, and it would cause the oil tank to become like a little balloon. You have to blow it out and try to keep it from popping. Oil cooler obviously just cools the oil, so you're gonna have oil that gets pumped up into the oil cooler, drops the temperature down, goes into the scavenger pump, then gets pushed into the engine oil sump or wherever it ends up going on the hierarchy of that in particular engine. That allows cool oil to go in there to help capture the heat and bring it down. Then you have your oil pressure gauge. That just simply it will tell you like where your oil pressure is at. Kind of a rule of thumb with troubleshooting is that high engine oil temperature usually indicates a low engine oil quantity, which you should see a drop in pressure as well, depending on the system that you're talking about. You don't want to have high engine oil pressure because obviously everything has limits, so you overpressurize the system. Boom, something could fail. Oh yeah, so let's talk about oil tanks. Okay, so engine oil tank. Let's just read the blurb out of the 8083, and then we'll kind of go from there. So the oil tank, constructed of welded aluminum, typically not all the time, but typically, is serviced through a filler neck located on the tank and equipped with a spring-loaded locking cap. It's also not always true. Just this particular example is one. Inside the tank, a weighted flexible rubber hose is mounted so that it's repositioned automatically to ensure the oil will pick up during all maneuvers. So as the plane tips and dives and does all kinds of things, that weighted hose follows the lowest point on the tank, which allows the oil to keep on, keep on entering the system. During normal flight, the oil tank is vented to the engine crankcase by a flexible line at the top. The location of the oil components in relation to other to the engine is shown here. All right, so you have position one. You have a breather that basically just allows the oil tank to have access to outside air, so that way it doesn't overpressurize and pop like we are just talking about. You have the oil outlet on position number two, so that's where the oil is going to leave the tank and then enter the system. Number three is the oil inlet, where the oil is actually going to come into the tank. You have a temperature gauge and an oil pressure gauge at positions 4 and 5 that allows us to just simply monitor the health and status of our engine oil and therefore our engine. Then you have 6 and 7 is the oil tank. So you have this gray or this greater apparatus up here in the kind of the top left. You can kind of see that's the whole crankcase and all where the engine oil is going to go. Then the tank is going to be on the outside. Now, this is not necessarily the case on all aircraft. Like IO 320, the oil tank is just basically on the bottom. It all comes down to the bottom. Some places have or some engines will have a remote engine oil system that will pipe into it from somewhere else on the aircraft. Usually, it's still pretty close by, but just know that you can have two different kind of configurations. We're going to get to what they're called here in just a minute. Anyways, you have the oil tank drain and vent line. Now, the drain is the part of the engine oil tank you're going to interact with the most. On your GA planes, most of the time there's like a little petcock that sticks out the bottom. You twist it up ideally with a hose on it, and then pipe it into wherever you're going to catch your old oil. That will come out and goes into. I'll put mine in 5-gallon buckets, and then we cart them off and go somewhere else with it. the you could have another scenario. I worked on an aircraft here recently that had like an actual plug, like on a car, and so that this is going to look different wherever you go. But essentially, every engine oil tank is going to have some sort of drain for you to get after. Then you have the oil tank vent line at position number 9. And then you're having engine oil pressure line. So that's where the oil is going to leave the engine oil tank and then go into the engine. So it's going to be under pressure and moving at that point. But other than that, essentially all an engine oil tank is just a collection point for engine oil. It's pretty straightforward, pretty simple. Okay, so a couple other components that go or in and around the engine oil tank. One here is going to be the scupper or scavenge oil screens. You're going to hear you'll end up doing these a lot whenever you do like annuals, oil change and stuff. You're going to pull the oil screen out, and that basically is going to screen out like a lot of large particles in the bottom of the engine oil case. Usually, if you find metal if they're really big, this is where you're going to find them at. Small ones you'll end up finding in the oil filter, and we'll get to that when we do oil changes. But on the scupper itself, like you'll end up finding like huge chunks. I found a piece of the internal part of an engine not too long ago in a experimental aircraft, and it was just like this big, huge chunk of brass where one of the internal components had come apart. Anyways, so the scupper basically sits on the bottom of the engine. This is what one looks like. It'll be like this long screen, and you generally don't want to see any particles in there. You'll see little bits of like carbon and blackness and dirt and stuff like that. And you just blow those out. The main thing that is really a cause of concern is if you find metal in there. You hear people talk about making metal, but this is part of just the engine or the oil filtration system. You want it to be nice and clean. That's always part of your oil changes. Okay, the other one is you're going to be your pressure regulator or your pressure relief valve. This is how you will adjust the engine oil pressure. What you can do is you can take that nut off, put like washers on there. Some of them, however, you can adjust with a screwdriver, depending on the model of the engine. So you'll always want to just go off of whatever the maintenance manual tells you to do to increase or decrease the engine oil pressure. If you have a situation where the engine oil pressure is super high and you just back it all the way out and it's still so high, then you've got issues somewhere else. So this is a step in troubleshooting faulty engine oil pressure. Okay, so your aircraft engine oil system is just like your car's engine aircraft oil system. It has a filter on it. The engine oil filters on most aircraft engines are a little bit bigger, and they have to be safety. You write the date and time on them whenever you install it, and so it's the same idea, just maybe a little bit more. Higher fidelity on the quality of work that you're going to do and the depths in which you're going to dive in an oil change. But this is what they look like. They simply just screw on to the engine case, and then you safety it off. Write the date, the time that the hours the aircraft was flown, and the date, and whenever you did the oil change. Now, the where it really gets different than a car or whatever is whenever you take it off. Now, typically with a car engine, you're just going to throw the filter away. Nobody really breaks the filter apart to inspect it. But on the engine oil, or on an aircraft engine oil filter, you're going to take it off. You're going to cut the actual filter element out of the housing, and then you're going to extract it. And we're going to show you how to do that in class. And then you take an X-Acto knife and score the filter housing on either side, and then pull it apart. And as you pull it apart, you're going to end up seeing little shards of metal in there if the engine is falling apart. If you don't see anything, the engine's good. It's going to go back in service. So most of the time, you don't find anything, but you always have to be really careful, and you want to look for it. Now, this guy's done a really good job. He's laid it out in a pan. Good thing to do is take a flashlight and go down the sides and look and see if you see anything glinting. If you see something glinting, that's going to be shards of metal, and that's something the owner needs to know about. Now, and then you once you have found metal, then you'll go to the maintenance manual and you'll do follow-on maintenance to try to figure out where that metal is coming from and try to fix it. Even though it may be painful and expensive to fix an engine like that, it's better to do that than find out about the engine eating itself at 4,000 feet in the air. But yeah, that's an engine oil filter. Not really that different. Like you have an engine screen, and then the filter itself, and then the filter you have to break apart. Other than that, it's pretty much like a car. Okay, so the next component we want to talk about is the oil pump. And so if you look at the oil pump, right here is the gear type pump. All that's really doing is you have two sprockets that are coming together, and as they come together, they squeeze the oil, and that squeezed oil then gets pushed out at a super duper high rate. And so you have like the super squeezed oil with a little port, and as those teeth come out with that squeezed oil in between them, it pushes it through that hole, and that helps elevate your oil pressure. Now that kind of goes back to what happens with low oil pressure. Typically, it's an indicator that there's not enough oil in the system. Now, you could have a situation where the settings are off, or maybe something else has happened. But the only way that you get really low oil pressure is that if you have air in between those passages of that sprocket, and that air then allows the oil to expand and not be so pressurized. So therefore, you likely have a small amount of or a low amount of oil in the system. But either way, they all kind of follow the same kind of construct: is that they go through the pump, and then they get pushed into some sort of filtration system or a valve right then and there. Then it goes up into the engine above it, and there's always a bypass valve. So in case there's a clog or something like that, you don't just have oil just explode and go everywhere. It allows it to go back into the reservoir, so that way you don't have to worry about like clogs anywhere in the system. And that's what that bypass valve and the relief valve is there. The relief valve basically means that, hey, look, it's going to like spew oil outboard if it goes, whereas the bypass valve keeps it the inside of the system. It just allows it to bypass whatever is clogging it up. Engine oil pumps happen or like are very common. You typically will have a onboard or a internal engine oil pump to the engine itself. You might have an external engine oil pump, even though I don't know that I've ever actually seen that, but it's feasible. It's possible, especially when you start dealing with more complicated engines. But yeah, that's really all there. There's not a whole lot to them. They're pretty straightforward. You're gonna have your pressure control device that's on there that you'll screw in, screw out, or add washers to, take washers away to close the valve or open the valve to allow springs or allow that spring to compress or expand and change the distance the valve is from the seating position, and that will change the engine oil pressure as well. So that is an engine oil pump. Pretty simple.
Let's dig into the details of a wet sump system.
Okay, when we say wet sump system, all we're talking about is the oil pan that you can clearly see in the very bottom of this engine. You can see that it looks like the exhaust valves are going to it, but it's not. It's actually, they just kind of end right there. But essentially, all a wet sump system is a integrated oil pan on the bottom that allows for the oil to come down to the bottom, and that becomes the reservoir. This is very common. This is what your car has. It is more common to have a wet sump than a dry sump. So if you know that the engine oil is at the bottom of the engine and that's where you're going to get your oil from, that is what a wet sump system is.
All right, now that we understand the details of a wet sump system, let's dig into a dry sump system.
Okay, so a dry sump system is nothing more than means that the oil goes through the engine and it comes out of the engine and goes into a reservoir somewhere other than on the engine. Whereas like your Lycoming IO320 that we were just looking at has a sump that is integrated into the engine and it sits on the bottom. A dry sump system comes off to a reservoir somewhere else. Now, all the parts and pieces that we discussed before are still present in both systems. They're just arranged a little bit differently, and arguably, the dry sump system may be superior to the wet sump system, because working on a dry sump system allows you to isolate components and change them out, just like the LRUs do in avionics. Rather than having it all integrated in one system, you can say like, oh, we have a problem with the oil tank. We just change out the oil tank, not a big deal. Whereas if you change out the whole tank on a integrated wet sump system like the IO320, it's a significant ordeal, because you're taking off the bottom half of the engine. So you have like little things like that to take into consideration. But those are the differences: wet sump, Y sump. A wet sump is on the engine. A dry sump is somewhere other than on the engine.